I'm starting to record now. Okay. The session will be recorded and will be shared with everyone. Okay. So nothing to worry. The slide along with the recordings will be shared with you. Okay. So everyone except the instructor is muted. Please ask questions by typing in the questions window. And I'll read out the questions before answering the questions. So please make sure that you write a little bit more legible language so that it doesn't take me too much time to answer your questions. Okay, because there'll be around more than 200 300 questions which I'll have to answer during these 3 hours. Okay, so please be a little considerate about my ability to read. Okay, great. So welcome all. We have, I'm expecting more than 40 candidates in the first session. From second session onwards, there'll be only few candidates. Okay. This first session is generally open for wide audience. Okay. And first session is open for everyone, as in it's a free session. From second session onwards, you can attend the session. Okay. And all right. Now, all right. It'll be great if we start with your introduction. It'll be great that I would know that who I'm talking to. So we have Asmeet with IT experience in two years. Great, Asmeet. All right. So I think we should jump in now. All right. Yes, Ashok, I'm getting your chat. Hi, Atri. Hi, Dirpe. Dirpe is from Yahoo. Great. Great to have you in the session, Dirpe. Okay. Dirpu. Okay. I get it now. Dirpu. All right. Hi, Dirpu. Dirpu is from Yahoo. And we have Vivek with a 5+ years of IT experience from TCS. Great. We have Ganesh from NTT. We have Leela with 20+ years of experience in Flagstar. Brilliant. We have great set of team here. We have Thiru, who has 12 years of experience in Java J2E. Brilliant. And we have Sundar and all right. All right. Great. We have Ashok from Xerox and we have Muhammad working in NIIT technology with 2 years of experience. Brilliant. So we have a great set of team. We have Vishnu from Cognizant with 7+ years of experience and Ajay and Rajiv with 20+ years of experience and Vijay with around 10 years of experience. Sundar having 6.5 years in Ab Initio, now working with Syntel. Brilliant. And we have Ajay from engineering background and manufacturing. Great. Prasant from Cisco as dev manager, 16+ years of experience. So Sukhvinder with 10 years. Brilliant. So we have actually a great audience today. All right. We have a great audience today. And let's go ahead with the rest of discussion. All right. Okay. Okay, so I've muted my all chats. All right, so I'm just waiting for one more candidate trying to call me again and again. So Ashok, it will be only chat for the first session. Okay. So we have Ashwini, who has worked in Quanticate and Mindtree, having 4.5 years of experience in Java, and currently uh, currently is a housewife. Great, great to have you, Ashwini, in the session. You're definitely going to enjoy the sessions. All right. So it is going to be a great course because we have great set of team in this one. All right. So here we go. All right. So I will start in a very simple manner. And today, be aware that today the course will be a little simpler. Okay. From tomorrow, it will be a little more technical. Okay. Today is kind of an introductory session and getting to know each other. From tomorrow, we are going to dive deep into the whole technology stack and understand the details of each and everything. Okay. And this course is a fairly technical course, fairly hands-on. So, but we will make sure that we learn in the right manner by asking difficult questions. We are by asking any questions at all, and by practicing a lot on CloudX Lab. All right. So a little bit about no big data. So no big data basically started with the mindset that we will have a great set of instructors, and for that matter we have great set of instructors. And then we built something called CloudX Lab, which other companies have also started taking from us, and I'm very happy to build this CloudX Lab. And as of today, if the candidate is not learning on a real cluster, they are not actually learning the technologies. Okay, so the virtual machine and other things did not suffice. That's why we built our own cluster on the real technology, the way it used to happen in my past experience in the real world. All right. So this is the best place for learning the real technology rather than learning only the theory. Okay. So the other thing which we have is lifetime access to learning management system. There is no limitation. We have all the slides, class recordings, assignments and quizzes, project work, everything in LMS. Now, the project which we are going to give is going to be a real life based project. It's not going to be real life, meaning it's not going to be with a company per se. We only give the projects with the real customer only if you prove yourself in this course well. Okay, so if you prove yourself in the course, then we will keep you in mind when we are starting a project with one customer, and only then you get to work with the real customer, because commitment as well as ability to deliver is a big concern when it comes to the real life project. Okay, so we provide you a course completion certificate with 24 by 7 support, and we have something called no big data alumni, where we keep on sending you all the we keep you stay connected with the latest jobs and stay updated with the course quizzes and complimentary sessions. And all right, so that this is about no big data. Today's session is going to be about understanding big data and Hadoop architecture. All right, so this is me. All right, this is me. Myself, I'm Sandeep Giri. I did my graduation in 2002 from IT Roorkee, and then I worked at a place called DE Shaw. The people from US must be knowing DE Shaw. It used to be one of the largest hedge fund and most technical company before Google's. Okay, so we had a 10,000 node cluster at the time when people did not know about cluster computing. Okay, so we were working on a huge data even before other people actually thought of that. You can guess the situation that the data that I was working on, we used to get it via plane or via the ship. Okay, instead of downloading. Why? Because it took long time to transfer the data by downloading. So ship or aeroplane was faster than the electrons when it comes to the volume. So at that point of time, we had done few good works in big data, and we realized all these difficulties the challenges which are quite difficult to comprehend unless you see big data. I mean, I never imagined that I would get my data via plane, okay, because it takes too much time to download it. Okay, so weekly we used to get the data. Right. Afterwards, I built a company called Tvits Global. So it's a document management system for large enterprises. Okay, so it's again into data management technologies. Afterwards, I worked with InMobi, where I churned around 200 terabytes of data and built a recommender. Okay, so instead of showing ads, we were showing recommendations inside apps saying, because of your history of playing with the apps, these are the apps you may also like. So on those lines, we built some solutions at InMobi. All right, then I joined a company called Amazon, where I worked on building high throughput stream processing systems. Okay, for and the first use case of my stream processing was to optimize the image, or to do the selection and optimization of the product image which is shown on Amazon's detail page. When you go to the detail page, the image which is displayed on the left top corner, the biggest image on the page, okay, that is something is being selected using my platform. All right, so we did that and also took care of the detail page. And then in 2014 May, I plan to quit Amazon and started No Big Data. Now, we're going to complete around 2 years, and we are very glad to see our overall performance for 2 years. All right. So, this is about me. All right. So, we have Mohsin, and Mohsin has worked on with Walmart. All right. Yes, I'm getting Mohsin, the chat messages. Okay, I am more comfortable this way. I hope you all are okay with this, because this way I can see your chats as well as I can see other things. Okay, all right. So this is, yeah, all right, all right. So let's start our discussion. The first question that you will face is, what exactly is big data? I'm asking this question so that we can establish a ground on which we will discuss everything. Okay, so will establish a ground around which we will have the complete discussion. So, what exactly is big data? What is your understanding of big data? Yes, anybody? All right. Leela says that it's huge volume. Good. Structured and unstructured. So, uh, so Shad, the question is that what do you understand by big data? Brilliant. Great. Great set of answers. Thiru, Vivek, Sundar. All right. Leela says the high volume structured unstructured data. Yes, Sneha, you have a question for me? So, Sneha, the way these discussions go on, for the first session, everybody is going to be muted. If you have a question, you can type in the questions window, all right? And then I can answer it, all right? Great, great set of answers. Vivek, Sukhvinder, Asmeet, Mohsin. Okay, we have good answer from Muhammad, Ashmeet, and Shad. Okay, there are two Muhammad, so I will say Shad. Other case. Okay, all right. Great, great, great. Good answers, Sneha and Mohammed. Great. All right. So we have great set of answers. All right. So yes. So apart from the typical definition, we will stick to our subset of problems that we will discuss across the course. Okay. So our definition of big data is it's simply a data of very big size that you cannot process using usual tools. And and to process such kind of data or to solve such kind of problems, you end up with a distributed computing. Either your own system or any third party system. So whenever you need a distributed architecture by virtue of use volume, size, or the rate at which you are getting the data, we call the problem as big data problem, or we call the data as big data. The data could be structured or unstructured. All right, great. All right, so here we will first like to define what do we mean by structured, semi-structured, and unstructured. So when we know about what is there, what are the fields in the input data, then we call it. When we clearly know that in the input data we have these many fields and these are the data types of these fields, then we call the data as structured data because we know the complete structure of the data. We know what are the fields as well as we know their data types. All right. The second is semi-structured data. Okay. So examples of structured data is the data in database. In database, when you create a table, you define the column data types. Okay, and you define the number of columns. So in a database table we clearly know what are the fields and what are the data types. In case of semi-structured data, we clearly know what are the fields, we know the names of the fields, we know the separation between the fields, but we do not know what are the data types of each involved field. For example, when you get a CSV file, you get comma separated values, which are not really saying anything about the data types. Okay, so in case of a CSV, you have to infer their data types and then you have to convert it from the string into the individual data type, whether it's number, boolean, or date, or whatever. So this is semi-structured. And the third one is unstructured data type. The data in which you do not know upfront that what are the fields, and knowing the data types of the fields is out of question in this case. So when you do not know the data types of the fields, then we call it unstructured. We do not know what are the fields in the input file. It may be a plain text file, it may be a binary object, it may be anything. Okay, so in those cases, we call this data as unstructured. So most of the problems involved with unstructured data are to convert this unstructured data to either semi-structured or structured form. All right, and such problems are also very frequent when it comes to the big data. Okay, so Sneha, I'll talk about distributed architecture in a minute. So Dirpu's question is, what do we mean by unusual, the usual tools? I'll come back to it. Okay, I'll come back to it. All right, so we talked about few things on this slide. One, data of very big size. Second, can't process with usual tools. Okay, so what do we mean by usual tools? Usual tools again are non-distributed in nature. And fourth one we talked about structured or unstructured data. So out of these, if you look at these 4 points closely, the most important one is the distributed architecture needed. And what do we mean by distributed architecture needed? Okay, so what do we mean by distributed architecture or distributed computing? So distributed computing means that you have connected the computers in a network or by some other means, maybe Bluetooth or whatever means, and you have divided the work. You have divided the work amongst these computers. Okay, so you have so the group in a formal sense, it means the groups of networked computers interacting with each other to achieve a common goal. Okay, so this is distributed computing. You have, it's not the network alone. You are dividing the work that needs to be done amongst these computers. Okay, and you will be amazed at the amount of efficiency that you can get out of dividing the work among so many computers. So Ashwini's question is, what are the examples of unstructured data? The biggest example of unstructured data is, let's say you have a web server or you have some machine, some web application which is continuously running and generating the text as the log. So whenever somebody requests a URL, it makes an entry into a file every time just to record who is accessing what URL. These are called logs. Okay, and in these logs there's a lot of valuable information hidden, information lying, not hidden, information lying, because it contains everything. But it's a plain text file. It's a plain text file which contains all this data, and you need to write a parser, or you need to convert this plain text data into columns, okay, and into structured data. So such kind of file is generally called an unstructured data, which just contain the plain text. Okay, and you have to understand this text in order to separate one field from another. So Muhammad's question is, whether forecast is unstructured data. You can say that if the format is wrong. Okay, yes, Sneha, you have a question for me? All right. Mohsin's question is, how big should be the data set to be called a big data? We'll come back to it in a minute. Rajiv's question point is that I believe that we should be able to see the chat of all participants. That way, we will feel like a classroom. Ideally, we should. Okay, ideally we should, and that's why what I do is in from second class onwards, I basically copy paste everybody's question into text window. Problem is that in this go to webinar, they do not allow seeing each other's chat, and in the go to meeting, the other tool, the chat is available to all the people, but the number of audience is limited to 25. Okay, so let me work it out. I do like the way if everyone can see the each other's message, my headache is reduced. Okay, because every time I have to speak it out. Yeah, Sukhvinder's question is, can we say that audit logs are a type of unstructured data? Okay, let me just say, yeah. So audit logs, if they are being generated by database, they have a proper format. Okay, so you do not need to do the processing of these audit logs produced by databases. But if you have a but if you have audit the okay, so but if you have audit logs generated by some system which you do not know the format or the parser, you might have to understand it first and then convert it. So you can say that audit log, yes, are unstructured data if you do not have a system already which understands audit logs. Okay, all right, all right. So, yeah, Ashwini's question is, when you say image or video is unstructured data, still image will have data type. Yes, image internally will have the data types, but you have to parse it to understand most of it. Okay. So Suraj's question is, does big data include large site document, audio files and video files? It includes everything, Suraj. All right. So Ashok's question is, XML is structured or unstructured? XML is kind of semi-structured. If you provide along with XML XSLT, then it becomes structured because that gives it the complete information about every value. All right. Great, great set of questions. I would like to go into a little bit more details. All right, so let's go to the classic definition of big data. All right, I'm not adding value, veracity, variability. I'm not including that. Okay, because that is little too much of distraction. Okay, so I'll focus on these three aspects, and across the course, these three characteristics of the data is something we are going to pay more attention to. All right. Yes, Mustaq, you have a question. You can type in the questions window. All right, I can read your question. All right, great. So apart from our definition, okay, apart from our definition of big data saying it's a distributed computing, I would like to explain to you what are the characteristics of the data which makes it big data. So the first and most important characteristic of data is the volume of the data. Okay, so the data could be such that it's in huge size. So the objective with such data is you have to store it somewhere. Okay, and when the storage becomes the problem, then you say that by virtue of the volume of my data, I will have to move to distributed computing, and therefore my big data is because of volume. Okay, so the data at rest could be you can see the example such as the storage of the data by Gmail, storage of data by in the form of logs, and in case of Facebook, there is 300 petabyte of data where they are generating a lot of data per day. Okay, so where do they store it? How can they store such kind of data? We will go into this detailed discussion into how to build such a system which can store any amount of data as we go forward. Then the second characteristic which might make data as big data is velocity. Velocity could be is best explained as data in motion. Okay, so data in motion, what does it mean? Let's say right now when I'm delivering this uh, this session, every byte is being transferred to more than 50 attendants. There are more than 50 attendees right now, and this kind of velocity of the data has to reach to every student on time. Okay, so this kind of rapid speed that is required needs kind of distributed systems. One system cannot handle all of this kind of load. There has to be multiple servers. Similarly, imagine that you have built this analytics tool which gathers data from all the websites and shows their statistics. Okay, even though the problem with this analytics tool is not related to storage, because let me simplify what I mean by analytics tool. Let's say you have built a counter, you have built a website which does nothing but counts the number of hits. Okay, and then if a website is getting millions of hits per second and there are thousands of such websites, so you get billions of hits per second. Now, to cater to billions of hits per second, even though all they are doing is increasing a counter on your website, right? Even though the data is very small, catering to so many connections per second is really, really difficult. Okay, you cannot do it without distributing the load, without involving many systems. Okay, so the other use cases of velocity could be that we we have a live system. For example, lots of people are placing orders on our e-commerce website, and we want to process this real-time data that and detect the fraud on our website in the real time. So in the real time, people are placing orders and we are doing some kind of churning of this data in real time to predict whether the user is on our website is using a stolen credit card or is using their own credit card. So this kind of analytics need to be almost real time. And for such kind of system, you cannot get it done without having a distributed architecture. Okay, so this is data in motion. Or the best example would be in the first case on Facebook, there's a lot of videos being uploaded. Facebook has to save them somewhere. On the other hand, every second, all of us are checking our Facebook status updates. So the number of requests Facebook is receiving per second across the globe is really high. Okay? And that need to be catered. All right. Third is variety. Variety is an interesting characteristic. And as we go into the details, we'll talk about variety a little bit more. Variety, we'll talk about two kinds of things. One, the variety of data that need to be processed and the variety of problems that you need to solve. And variety and complexity of our problem statement, they both lie in the same bucket. Let's take a case, let's take a very obvious case which we probably use at least once in a week. The Google Maps. Okay, the Google Maps. I have to find the way from one place to another. Okay, even though the maps would be small, it won't go beyond few gigabytes. Okay, and there is not much of a velocity requirement, although sometimes it is. But for argument's sake, let's say we are just finding the the way from one location to another. Okay, in a reasonable amount of time is okay in a reasonable amount of time, say 10 seconds. All right. Now in this case, the velocity is not too high. Our map is not changing that fast, or our request, there are not many requests. And the only thing is that we have to give answer in a reasonable amount of time. So, how do we solve such kind of problem? Even though data is not, volume is not there, velocity is not there, but finding path from one place to another in a map is a complex process. You will have to iteratively try all possible routes from one location to another and come up with the best one. Okay? If you think about such kind of process, it is actually quite complex. Okay? It is actually, if there are n number of circles in this map, circles as in the cross sections, and there are m number of streets in this city, then the total number of paths from these one place to another would be n into m, which is uh, it, it's very complex to iterate through so many number of ways. And when the map keeps on growing bigger and bigger, the complexity keeps on exponentially increasing. And 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 these kind of problems are quite often, so these kind of problems push you to convert your problem into a distributed computing problem so that many computers together can solve your problem. All right, so in these three cases, whether volume, velocity, and variety, by any of these virtue or more than one of these, your problem could become big data problem. Okay, your problem could become big data problem. All right, all right. Is my voice clear to everyone? Mustaq is saying that my voice is breaking. All right, great. Everybody is able to hear me clearly. So Mustaq, maybe some problem on your end. There's a question from Mustaq. Question is, okay, not Mustaq. Asarfi's voice is complaining that voice is breaking. All right, all right, yeah. So the question here is, Mustaq is saying, will big data replace surveys in future? Very brilliant question. So, for example, I'll talk a little bit about. So, can I park this question for a while? Okay, this is the question. I'm keep parking it here, and we'll take it up once we are in that mode. Okay, it's a good question. I would like to answer it. All right, just a little later. All right, so I hope it is clear. Now let's run through a quick exercise. So what do you understand that how many bytes are there in petabyte? I know all of you know it. Just to check whether you are listening to me or not. Okay. So how many bytes are there in a petabyte? Good. All right. Brilliant. Brilliant. So almost everyone has answered it correctly. Almost everyone. Great. So the answer is close to 10 to the power 15, meaning close to 15 zeros, those many bytes. And the way you can remember is kilo, mega, giga, tera, peta, exa. So when peta is basically coming after tera, that means it is going to be 1024 times the tera. All right. So and what is a byte? Byte is nothing but a bit, eight bits. All right. So yes, you are right, Ashok. It's 1024 to the power 5. Okay. Now we know the numbers. We know the numbers. Let me understand. If you understand actually how does it feel like a petabyte? Okay. Let me ask you this. Here is a question to all of you. If you have to just count, if you just have to count number of vowels in 1 petabyte data every day, can you do it? Do you need a distributed system? Or, in other words, is 1 petabyte data big data? So, if you have to count, uh, yes, Sneha, you are not able to hear me clearly. You have raised your hand. Hmm. All right, let me just message Sneha. All right. Yes, you are all right. This batch is just wonderful. This current batch. So Ashmeet, Ashok, Atray, and Thiru, Sukhvinder, Leela, Snigdha. Good, very good. All of you are agreeing that it's a big data. All right. Ashwini says that it can't handle in with the single machine. Now, Mohammed's question is depends on processing time acceptable. Just to here, if you say the everyday is the keyword, Abu. So, so every day is a keyword. So, question is, can you do? Yes. So all of you are. So Sayed's question point is that parsing 1 petabyte data in a normal DB2 will take approximately 2 to 3 days. And Sayed, actually, that's a time required for maybe few terabytes of data. Try just copying 1 petabyte of data from one hard disk to another. It'll take around 12 hours. Good answers. Great set of answers. All right. All right. So, yes. So, yes, 1 petabyte is actually a big data. And in this context, so whenever we talk about data, You can do many things about it to the data. You can just talk about it. So talking about 1 petabyte data does not require big data system, right? Or or just counting 1 petabyte data across all of your users' home machine does not mean you're talking about petabyte data. Okay. What is important is that even a very simple work, such as counting number of vowels, is something cannot be done. And you must, all of you guessed it right, that it's not the processor that is the bottleneck here. It's not the processor, it's the limitation of the hard disk. You take 1 terabyte of movies from your friend and you try to copy it to your hard disk. You know how much time does it take to just copy 1 terabyte movies from one hard disk to another hard disk? Anybody? Any guesses? So first, yes, 1 petabyte is big data, and now I'm talking about how to time taken to just read 1 terabyte of hard data from a hard disk. And please note the problem I asked you about moving copying the data from one hard disk to another involves writing. Writing is even slower. So even the reading, okay. So let's talk about first reading. Okay. So Sukhvinder and Sundar, how much time does it take to read 1 terabyte from a hard disk? So Leela's question is, it all depends on how fast is CPU and the hard disk is. So the question is, does CPU matter in this case? Most of the CPUs are actually pretty fast. Okay, let's assume that you have around 1 gigahertz processor and a usual hard disk. Arun says will take around 3 to 4 hours. And Asmet says that we need SSD. Mohsin says that what is the storage capacity of largest computer today? Okay, so it all depends which computer are we talking about. So on an average, a computer, even on servers, cannot have more than 10 hard drives. Even if you connect 20 hard drives, it's going to be extremely slow. Okay, because because reading from the hard drive is going to be going to take a lot of time. All right. All right, that's right. Yes. So the hard drive speed matters here. The CPU doesn't matter. That's right, Sukhvinder. And yes. So on an average, it takes around 6 hours. So the question here are multifold. Question here is, first, let's understand the CPU does not matter much. On an average, you get the CPU really, really fast. And as an experiment, all of you, if you try to replace your hard disk with a solid state hard drive, you would notice that your computer has suddenly become really fast, or you increase the RAM of your computer to something else. So, the CPU hardly matters in most of the computing. It's generally the RAM or the hard disk which leads to sloppiness, as opposed to the common belief that it is the processor. Okay, so coming back to the point here, when it takes 1 terabyte, it takes six hours to read 1 terabyte from hard disk. Now you can see that for 1 petabyte data, it will take minimum of 6,000 hours. Okay, 6,000 hours, which is 50 days, just to read, just to read 1 petabyte data. Yes. So Mohammad's question is, so number of files does not come into picture. So this is the best case scenario where you are not looking up the files. If there is a looking up for the file involved, then it's further slower. Okay, it's further slower. Good question. Good question. So here we talked about a very simple problem. Just going through the videos. Okay. All right. All right. Let me just check if one of the student Parvez was able to join. All right. Okay. If Parvez is around, you can say hi because yeah, I could not pick up your call. All right. Good. So now another thing is that this graph basically is a very important graph. It basically shows that around 2002, the digital data accumulation started increasing exponentially. Okay, it started increasing exponentially. Hyperways, good, good. So this is what it shows. So digital storage, as in the data in the any digital media, while the analog means storage on the paper, storage on the tape drives. Okay. Now, why did it suddenly became why did the why did the big data, the digital storage started expanding? Why is it important now? Why does it matter to us now? What has happened because of which we are having a course called big data? Okay, so first is the data explosion happened because of which the ability to store it, process it fast, as well as solving complex problems have come into picture. And the reason is threefold. First, the devices. The devices, if you think about devices, they are data generation tools. Mobiles are nothing but data generation devices. Okay, you have got these smartphones, so many sensors. The smartphone is having better processor than the supercomputer of 2002. Okay, the smartphone on which you play Angry Bird is faster than the supercomputer which was envisioned to solve the problem of the biology and the DNA. Okay, so on one hand, the smartphones becomes really smart in the sense that they have so many sensors, they have so many good, so many high memory, and and the processor, and the ability to store so much of data. On one hand, such devices became cheaper, faster, and smaller. If you go to any hardware manufacturer, they will have these three criteria. One is cheaper, other is faster and smaller. On one hand, the hardware kept on becoming cheaper, faster and smaller. On the other hand, the connectivity between things and the people became more and more. The connectivity in the sense now you have 3G, 4G, and Bluetooth, and the infrared, and then you have NFC. So there are so many way and Wi-Fi. There are so many ways devices, people, and things are connected. Okay, so on one hand devices became really connected, the connectivity problem was very well solved. On the other hand, the the devices became faster, cheaper, and smaller. Because of these two reasons, more and more data kept on getting generated. On the other hand, these tools which let people easily share their stuff, stuff or share the information, made the data accumulate more and increase more. Okay, so this is the reason why the data explosion happened. Now quick question to all of you: which components impact the speed of computing? CPU, memory's read speed, disk speed, or disk size, and the network speed? Okay, or all of above? Which of these components impact the speed of computing? Okay, so Sukhvinder's question is, what is NFC? NFC is a near field communication. Okay, as of now, near field communication is there in almost all the devices. Okay, at least on the Nexus devices, you can tap two Android phones. Okay, and it'll basically transfer some information from one phone to another. Say for example, I want to share a file with you, I can tap the two phones. All right, all right. So yes, you all are right. All of these impact the speed of computing, as opposed to the common belief that it's only the CPU which matters. Okay, because of the advertisement and because of the all ad campaigns, it seems to all of us that the only thing that matters in a computer is the CPU. But when you see, if you are running a server, you will soon realize that actually the first bottleneck you will encounter is the RAM, not the CPU. CPU is probably the last bottleneck you will encounter ever. Okay, first bottleneck you will encounter is the RAM, and then the disk speed, and not even the disk size. And that's why if you are running a server, taking a good RAM and taking solid state hard drive makes a lot of sense. Okay, so for example, I was running no big data for quite some time with 512 MB RAM and a solid state hard drive of 20 GB. Okay, and the processor was half gigahertz. That is something which none of you would be able to believe, and the website was just doing wonderful. Now that since users have increased, we have lot of quizzes, lot of courses uploaded on the server. Now we have to move to 1 gigahertz and 1 GB RAM. Before that it was just wonderful, just because just because of just by increasing the RAM, everything was fixed very well. So it's generally the other things than the CPU which becomes the bottleneck. Okay, it's only the last case, which is variety. The third characteristic we talked about data, the variety, that generally leads to the CPU bottleneck. Okay, that generally leads to the CPU bottleneck. Sukhvinder's question is, I have three laptops. Is it possible for me to build a distributed system? How difficult it is? It's not very difficult. Okay, it's not very difficult. We can talk about it in the second session. All right. So it's not very difficult, and with three laptops, you can make a wonderful network. All right. Good. So again, yes, Somali, you have a question. Please type in the window. Yes, Sneha, you have raised your hand. All right. Now let's take a look at Sneha's question is, can I build a distributed system in the same laptop? It'll be you can definitely by having multiple virtual machines installed on the same. But again, it won't be first, it will be very slow. Second, it would not give you any benefits. Okay? It won't give you any benefits because it's the same CPU, it's the same hard disk, which is being utilized by three virtual machines. Okay, but definitely theoretically you can build a distributed system using a same laptop. All right. Yes, Parvez, you are right. Good. About the virtual machine. Good. So let's look at the four pillars of computing. I know that this is really basic, but what I found is that this kind of understanding is something has helped me a lot. Okay, every time I look at the data, I think about all these four things. Okay, and whenever I look at the data, I look at the problem, I ask the question like, how big is the data, and what is the rate at which it's accumulating, and what problem are you solving, and what time are you expecting the results by, or how frequently you are looking for the results. All right, so those are the questions, and these questions you will get more, you will be able to ask better questions if you actually understand the way a computing is done. Okay, my objective with all of these sessions is that you understand the basics of the things. It should your get into your habit uh, to understand and look at the problem from a distributed computing perspective. Okay, all right. So somebody came to me saying that they have bought a very high end server and they have cut it down into around 20 virtual machines so that they can utilize this system really well, which was actually funny for me because you don't need to cut it down into virtual machine to utilize it. That's unutilizing it or misutilizing the device. You will understand it when you think about how the computing is done. Okay, so there are four things on which the computing stands: the CPU speed, RAM speed and size, network, and disk size and speed. On top of it, there is a software. Okay, and out of all of the things, software is something which you can change and make it work. But that's secondary. That's something we'll talk later. Okay, let's try to understand the hardware first. So there are these four pillars on which that defines a computer. Although the wires that connect the CPU and the RAM, they also matter a lot. Similarly, the wires that connect the network to the CPU, they also matter a lot. But these four things are the basic ones. So CPU speed, how fast can it read the data and process and take that call? How many instructions can it process per second? Okay, that's what CPU speed mean. Okay, second is the RAM. The RAM's speed as well as size, both the things matter a lot. So whenever you talk about RAM, you should know is how fast can you read or write to the RAM. Mostly the CPU reads and writes to the RAM, and every time we have a problem, we generally load the data into RAM. And all the algorithms you must have studied in your course, almost all of them assume that the data has been loaded into the RAM. The whole tree, the tree structure, linked list, this, that, almost everything is assumed to be loaded into the memory. Okay? All the sorting algorithms assume that the data is in the memory, except for few. The new ones that got introduced in last 5 years, okay, except for those. The third thing is the disk speed and the size, and fourth is network. And network is something which we miss. Network is something which we miss. Okay, so let's take a case of you are running a server and the memory is going uh, overflow. Okay, you as a programmer, you will shift the bottleneck of RAM to the disk. Now, when you shift the bottleneck from the RAM to the disk, meaning you started uh, paging the data. If you remember the term paging, paging means if you can't fit into the RAM, put it in the disk. Okay, that's called paging. Next is when you put the data, we start pushing the data out of the main memory and putting it into the disk. Then the disk read speed will become the bottleneck. Okay, so we keep on shifting and try to shift the bottleneck from one device to another in our usual course of computing. In our usual course of development or administration, we try to move the bottleneck from one place to another. Okay? Let's say we increase RAM drastically, our CPU might become the bottleneck. So, when we deal with big data, any of these four components will become such a bottleneck that you cannot solve. When we deal with big data, at least one of these components will become such a bottleneck that you cannot solve. For example, see if you have a complex algorithm which is running instructions many times, it might take a long time for CPU to process. So CPU might become the bottleneck. If you are loading a lot of data, then the RAM can become the bottleneck. Okay, so you will try to move the data from RAM to somewhere else, and then your disk will start becoming the bottleneck. Okay, and if the disk speed becomes the bottleneck, you can't solve it. Though, if the disk size becomes the bottleneck, you will push the data over to the network, and then network speed will become the bottleneck. So, when we deal with big data, at least one of these four components will become such a bottleneck that you cannot get over with. You cannot get out of that kind of bottleneck by increasing the hardware or by increasing anything. Okay, so question from Ashok is that is it mandatory to know Unix to implement distributed system? Not much, just the basic one. All right. Okay, so we have Dare from Nigeria. He joined because of the okay. Uh, all right, don't worry, Dare. We will share the recorded video with you just after few hours of the session finishing. Okay. All right. So at least one of these will become bottleneck. Now, we talked about all the problems associated. We talked about how does it why the data started expanding so much and why it's difficult to churn the data using these all systems. Okay? The question is why do you need big data? Why do you need to learn any of this? Is there any use of big data computing? Okay? So everybody will get the video recording, no worries. All right, I'll send you the copy of this, but that does not mean that you don't pay the attention right now. Okay, so ask questions, and that's the only way to learn. This is my strong belief that unless you ask questions, you are not learning. Okay, all right, so why do we need to learn all of this technology? Why do we need to manage the data? Why can't we just delete it and forget it? And why do we need to maintain so much of history of the data, and we can just archive it or put it somewhere and say that it's not my problem anymore? Okay, there are usefulness which comes from big data. First, the first thing which is not there in the slide, I would like to digress a little bit. So in earlier times, in say around 15 years ago, when people were working on AI and machine learning, the common problem was that the data was not available. Sufficient data was not available for machine learning to happen. Okay, because if you have only few data points, you can't plot a graph properly and you won't get the results. And that's doubly true if you are trying to do a machine learning. Machine learning is teaching machine to do the from the arbitrary data to do the output. Okay, based on the arbitrary input and output of the past, it will try to predict the future. Okay, if you have used Excel, and it'll try to predict what you're trying to do. That's partially example of machine learning. So earlier, most of the one of the biggest problem with machine learning was that the data was not available, neither the tools were available to do the computing. Now, after the newer tools, the distributed computing came into limelight and proved that yes, we can handle petabytes of data, then that opened the door for the systems like machine learning. And that has changed the way the world works, and that has changed the way, and that's continuously the impacting the whole technology stack. The machine learning is actually improving every aspect of life. Okay, we'll go through a couple of example of machine learning. Say we'll go through recommendation, we'll do other things. Okay, all right. Okay, so Vijay's question is, when did these tools got introduced? I mean, how many years ago these tools came into existence? Just curious. So basic thing was that most of these tools were in-house. Okay, at D Shaw, the place I was worked in 2002, we had a good enough distributed architecture lab. Okay, really good one, meaning we had 10,000 computers connected and working. If you search for Disha's news, you will see a news in 2005 or 2006 showing mentioning Disha having 10,000 nodes cluster. Okay, and we were operating that for quite some time. Similarly, there were many companies who were having distributed computing infrastructure, but they were not making it public. Okay, it is just when Google came around, and Sanjay Gahmawat and the Jeff Dean and one more person, they published a couple of papers. Similarly, on the other hand, Amazon published paper on Amazon Dynamo. Only then the revolution started, because all other small players were shutting down their shops because they could not handle traffic, they could not handle data. In 2003, 2004, I remember very well people coming and meeting me asking that how can they handle that kind of traffic. Reason was that they could not scale to cater to a country. They always were able to scale up to 100,000 users, but not beyond it. Okay, so that time some people started building these tools, and that became, I mean, based on these few papers, and that brought the technology into the mainstream. All right. So there are few questions which are little different. I mean, not related to the current slide. I would like to take those now. Question is, I don't know Java. Is it a bottleneck for me? So that's Ashok's question. So not really, not really. Most of these tools are flexible, except for MapReduce in Java. That is our session four or session five. In that, that's designed for Java programmers. Okay. Other than that, all 12 sessions is open for all. And moreover, we have a Java self-paced course. I have just recorded my classes I gave to all the students so that they could attend, they could learn Java. So I've tried to create a crash course and record it, and it's available in my courses in the our LMS at No Big Data. All right. There is a question from Anand. Is there any role for RDBMS in big data? Of course. Of course. So most of these systems are moving towards RDBMS. All right. I'll take your questions. Yeah. Most of these systems are moving towards RDBMS. They're trying their best to build a system in which people can just write a simple query like SQL, and they can get the results without having to write a piece of code which will run on multiple computers. So this SQL queries, an example is Hive. Example is Spark SQL. All of these tools are designed so that the people with the RDBMS background can do the quick computing. All right. Sneha's question is, here we will write programs or just queries, both. Okay, some, so it'll be full range of things that you will be doing as part of this course. First, when we talk about MapReduce, you will be writing conceptually the strategy. Then we will also talk about Pig, where you will learn a new query language that you will be applying. Then we will use standard SQL for Hive, and then we will use other simple commands for HBase, NoSQLs, and so on. Okay, so be open for all kinds of exercise. Wow, these are so many questions. All right. Uh, so Snigdha's question is, where can I find the recorded videos? If you have enrolled for the course, it will be under my courses. Okay. Under my courses, if you log in onto our website, you will see under my courses, and there will be the recorded videos. Okay. Somali's question is it worth doing certification in Hadoop? All right. It's very perspective. It's a very uh, difficult question to answer, but I strongly suggest, whether you do the certification or not, I strongly suggest that you learn the technology stack. Okay, exercise on it. That's more important. Exercise on it, because the companies which have the big data infrastructure, they will have people who will interview you. They will not honor any certificate. Okay, the people who are have a technical strength in big data. But there are many companies who are not having big data team. They might look for certificate. So yeah. So Dare's question is that in one of my videos I have talked about Spark R. Are we going to touch base on Spark R for this batch also? So Spark R is only introduced for this batch only. Okay. In this upcoming batch, I'll be adding Spark R. All right. Because Spark R did not, the older version did not have R in Spark, so this one is the one. All right, and that's why we keep on, and be aware, all of you, please be aware that the class, although it says that it will go for 12 sessions, in case there are more queries, in case there are more doubts, in case the topic expands, it might go for 15 or 16 sessions. All right, because there's no point in rushing through the topics without having to cover them in details. Okay, so I try my best not to run away from the questions and skip the questions, because if I skip the questions, the whole session will be black, I mean, kind of, uh, you won't be comfortable in attending rest of the session. So that's why I want to make you aware that it might take more than 12 sessions to complete. Okay, specifically because we are including Spark R or maybe Spark SQL in this one. Okay. Wow, these are questions. All right. All right. So, all right. Muhammad's question is, which programming language is having upper hand? So, not much, but I would strongly recommend that you should go through both quickly, Java and Python. Do not get stuck. Do not get stuck with any of the language. So we'll not be touching C, C++. We will either be working with either Java or Python. Okay? And sometimes cell. So do not get stuck with the language. Just focus on the strategy, the algorithm, the way we use the tools. Okay, and that's why I have included the small Java crash course, and we might go with the introduction of a little bit about Unix and a little bit about Python. Okay, because probably if I had to just learn any programming language and I don't know any other programming language, I would just go with Python as of now. A question from Parvez is, can we be able to provide the bundled app to our users for doing analytical work? Okay, okay, this is something interesting. I need to think about it and maybe I want to discuss it more. Can will we be able to provide the bundled app to our users for doing analytical work? I want to understand the question a little bit more. Okay, all right. So Snigdha's question is, okay, so still you can go and sign up with the course and enroll from our website, nobigdata.com. All right. So question from Leela is this course good to move to Hadoop architecture? Yes. So Smeet's question is, which certification is best for Hadoop? Um, Good part is that up till now, only Hortonworks has included the hands-on exercise. Now Cloudera has also moved to totally hands-on. So whichever certificate you take, okay, on one hand you have a new company called Hortonworks, newer, slightly newer, because they built Hadoop 2.0, while Hadoop 1.0 was built by Cloudera and it's open source. So either of the certificates should be good enough. Okay, although the people who are demanding for certificate are generally little old school and they are generally asking for Cloudera. Okay, is that does that answer your question, Arun, as well? All right. So Somali's question is, I would like to do a certification. How can I prepare? A preparation, if you want to do a self-study, I would recommend the definitive guide, okay, other than this class. All right. Definitive guide along with CloudX Lab. Okay. Any lab setup. If you can set up your lab, nothing beats it. But do a practice on a real lab. I do not have a working experience of Big Data Hadoop. After this course, yes. So, could I keep up with the hands-on? Yes, of course. We are strongly of the opinion that if you do not practice, the whole training is not useful. So, even after the course, if you want to keep the access of CloudX Lab, you can extend your CloudX Lab access afterwards as well. Okay. All right. All right. That's like too many questions. All right. So Vivek's question is, will this experience be enough for other companies to consider? Yes, that should be good enough actually. Just that there are many companies who are hesitant in picking up the freshmen, but if you have an experience in any programming, that will help you getting selected. Okay. Because everybody understands that it's difficult to get people from the industry who are already hands-on, who have already good number of years of experience in Hadoop. Okay, so I'm just sending you the link to the website. All right, you can just go to knowbigdata.com and then enroll. So Finder's question is, how deep knowledge of Java or Python need to work on big data? Not much. You should basically know the basics. That should be good enough. You should be able to make the code. I'm not acquainted with any query language. Would that be a problem? So we'll be teaching you the big Latin, okay? And it'll be great if you just go through SQL basics. Okay, it would take maybe a day or so. I would strongly recommend that you go through the SQL basics. Okay. Okay. So Suraj, you can just drop me an email regarding your enrolling for the course, and you can just email us at reach us at no big data, reach us at okay, reach us at no big data, and we'll take care of it. Okay, his query is related to if you can enroll um, right away or tomorrow, day after tomorrow. Okay. Leela's question is that uh, she's she's not a Java person, but a big time PL SQL person. And what do you suggest for me to get in as a developer or an architect? Okay. So, all right. So the first two you can take care of, because if a PLSQL Oracle person is more like good enough in data architecting as well as development, so I would suggest that you go with any of these roles: a developer, architect, or an analytical role. Generally the first two will be better for you. For analytical, background, a little bit background in statistics is appreciated. Okay, similar is the second case. The first two will do good for you. So Rajiv's question is, are we going to get access to HDFS during this class to play? So for our students who have enrolled, they already have all the access. Okay, so you would see in your my course, if you go here, since I have access to all the courses, so here this section is coming from CloudX Lab, and this would give you your login password with which you can log into the cluster. Okay, because every student has got their separate account, therefore we have built this. Okay, so you can just copy paste, or you can go to Ambari Hue, and we'll talk about it a little bit more. All right. Yeah, definitive guide means it's a book. All right. Suraj's question is Spark and R same? No. Spark is a compute engine, while R is a programming language. Spark can be operated by using Java, Python, R, or SQL. All of these languages can run on top of Spark. All right. So Vijay's question is, you said that there are not many people with experience in Hadoop available. Okay. Is it because so it's both actually. Technology is comparatively new, and second is then the demand is more than the supply. Both. Yeah. Is Hadoop the only big data DB? Let me just complete this. I think it's the time that I move on because these questions will be answered as we go ahead. Okay. All right. So a question from Atrey is that a good place to learn SQL basics? Just go with W3C. Okay, that is probably the best source. All right. A question from Asok. As you told, the language is not an issue. Then what is the main thing that we need to learn to big data? The thing is that you need to know any one programming language, and that should be good. All right. A question from Dare is this class also relevant for the professionals doing analytics with small companies like a research company? So my quick answer would be uh, no. If you do not have any hands-on experience in the programming, because this is more like a Hadoop development class. You start, we go deep into all the tools that are required for the whole technology stack instead of analytics tool. And in analytics class, you generally go with statistics, statistical inference, and other things. Okay, so there is some class called big data analytics which we run from time to time. That one may be useful for them. All right. So Suraj's question is, do we learn R in this course? Quick answer is no. We just go over few use cases so that you can dig deeper into Spark R. That I need to actually think about because we have not done Spark R yet in the previous course, a previous session which finished last week. Okay. Hadoop engine is written in what language? Quick answer is Java. All right. Let's move on to the next sessions. Okay, let me just save it before things go. Okay, so it's 6 Fab session 1. All right. So Ajay's question is, I have a good background in statistics. What would you recommend for me to get into analytics? I would go for. I mean, I would suggest you to get into a role of either a data scientist. Okay, why can't I? All right, data scientist, or you could you could take up a big data analytics course. All right, and yeah. All right. Rajiv's point is that Spark is something to which I'm looking forward to. Please add 1 or 2 sessions to it, at least for some practice. Sure. Okay. All right. Snigdha's question is that big data analytics course is completely different. So big data course is kind of more into using the technology than getting the understanding of the technology. Okay. From the end user perspective. All right. So I should. Okay. Let's take a break for 10 minutes and back by say 10:23 p.m. IST. All right. So I'm back. Is everybody back? Are you able to hear me clearly? All right. Great. All right. So, okay. All right. Ashwini's question is, will you explain about MongoDB? No, not in this course, but we will discuss the similar architecture. Okay. Uh, okay. As part of NoSQL. Okay. All right. So all of you, the career related question, can I take one on one? You just drop me a mail on reach us at no big data. Okay. So the career related questions, I would like to take it there. All right. And because that's very one on one, I can't discuss that with everyone. Okay. All right. People coming from Ruby Rails will help in big data. Yes. Okay. All right. So we were about to start with our example big data customers, and I like to go through one example each, and then we take the further questions. All right. Ashmeet, we discussed NoSQL in session number 6 when we discussed HBase. So today it won't be possible to discuss NoSQL, but there would be a video on my our YouTube channel of No Big Data regarding NoSQL. You can go through that. All right. All right. So let's talk about example big data customers. Okay. So the first and foremost is a recommendation engine. So recommendation engine, I would like to go forward and then we'll come back. Yeah. Okay. So recommendation engine is something which was the first use case of exploiting humongous data. Okay, this is most common example of exploiting big data to increase sales, improve user engagement, and many more things. Okay, so there could be many different kind of recommendations. Okay, starting with people who bought this also bought this. Okay, and we are where this with that, while on the right hand side the recommendations are very much precise and hand curated, while on the left hand side the recommendations are automatically generated. The great part about automatic generated is that they are more precise if you have significant data. Okay, they could be really bad if the data is insignificant. All right, on the right hand side it requires a lot of manual work to do this kind of thing, and even it is very error prone. All right, the most significant use case of recommendation was given by Netflix by giving the movie recommendation based on the past ratings. Okay, so based on your history of liking or disliking, it gives you the recommendations of which movie you might like. There are many more ways to do that, and the most common one is figuring out figuring out who are similar to you and doing the cross selling. For example, out of all the people who are attending the session, maybe my choice is very much similar to Dare, or say my choices are very similar to Asmeet. Okay, maybe me and Asmeet both like Matrix. Me and Asmeet both like some other movies. So our similarity is more than dissimilarities. Then it will start giving recommendations to me about the movies which Asmeet has watched and I have not watched. And similarly, it'll give the recommendation of my movies which Asmith has not watched, and so on. So basically, so there are many more strategies, many more different kind of algorithms. I'm just describing one of such algorithm. Okay, and the most beautiful part about recommendation is that recommendation has been solved by so many different people in so many different ways that it has become available as part of the common library called Mahat. There is a full list of algorithms which Mahat supports. Okay, and you don't have to do any coding. Trust me, you do not have to do any coding in order to do the recommendation engine. We'll walk you through this example of generating recommendations whereby we will give Mahat three column data saying this user likes this movie and this much. Imagine an Excel sheet with three columns, and that's what we will feed to Mahat. Mahat is a command, okay, which nothing but under the hood it uses Hadoop, okay, and couple of algorithms. So we'll tell Mahat that hey, here is my three column data in the form of CSV file, and can you give me the recommendations? And Mahat will give me again three column data with the recommendation that this user would like this movie and this much. My hypothesis, it's Mahat's hypothesis saying that this user will like this movie this much. Okay? Or they will rate this movie this much. The second problem, which is very well solved with big data, is sentiment analysis. Instead of gathering surveys, the way people earlier tried to figure out how good is the movie. Okay, they what they used to do is just outside the movie hall, movie cinema theater, there will be some people who will be asking questions, okay, to the various people, collecting the data set or doing the survey, gathering the survey results, and then based on statistical analysis we could come up with the idea whether people are liking this movie or not. But that was too much time consuming and full of different kind of biases. So instead of asking people this way, you could just go through the social feed. Okay, you could just go through the social feed and see how many people are liking a movie, how many people are talking about it, are they using negative words with movie or positive words with movie. And accordingly by understanding the text, you will come to the conclusion that these many people or these many tweets are there which like this particular movie, and these many tweets are there which do not like this kind of movie. So we will go through a Twitter use case whereby we'll do the sentiment analysis in the last session. All right, so these are the two main problems for which big data is used. Next is, so we talked about recommendation engine. Second is the search quality. Okay, so sometime a lot of times search to improve search quality, you need to you need to process a huge data. Okay, let me first look at your questions, okay, so that I don't miss out on your questions. All right, Mustaq, just hold on for a few minutes and I will go into the definition of Hadoop. All right. So, with respect to the search quality, okay, so let's say you're building a small search engine for your corporate network. Now, you would like to improve the quality such that if a user is typing a word, you are able to give the recommendation. Also, you are able to figure out that what are the different meanings of the same word. To do so, you would need a big dictionary, and that kind of dictionary you need to prepare by crawling a lot of data. And that lot of data is big data. Okay. Third is sentiment analysis, which we have already discussed, and fourth is A/B testing. Okay. If you have heard about this term, you must have heard it in terms of the medical ones. So before a drug is given and approved, before a drug is approved, the drug is given to a small sample set of people, okay, who enroll for testing for the drug. Now, so similarly, there is one sample set to who the drug is given, and there is another sample set to who the drug is not given with the similar symptoms. Now, you observe both sets of people and then see the effect of drug, see their behavior with and without the drug, and then you reach to the conclusion that whether drug is impactful or not. Okay, so this is called A/B testing. You have A and you have B. You have two sets, A and B. A is somebody with the treatment to who you have given the treatment, and B is the other the other set who has not been given the treatment. Okay, and then we compare whether giving the drug solved the problem or the problem got solved automatically. So this is called A/B testing, and A/B testing is a very important thing in case of IT industry. So for the case of Amazon, the so since I was in the detail page, for me, A/B testing mattered a lot. Whenever there is a new feature that comes up, it's given to only 1% of the user, randomly selected. So different users actually see different page based on this random selection. And then we observe that which one gave us better sales, whether the blue button is giving us more sales or the green buy now button is giving more sales, and accordingly we decide whether a particular color is good or not. All right. So these are the impacts of A/B testing. In telecommunication, the impact of big data is huge. It is used for customer churn prevention by figuring out why are the customers leaving you, by understanding how many calls they gave before they decided to pull the card. Okay. Similarly, how many times their network was out of coverage area, and so. So by understanding the user's behavior, you can actually predict why are people leaving us. Okay, why are our customers leaving us, and and how can we prevent them. Second is the network performance optimization. Okay, so based on the past behavior of the users, the telecoms can predict what is going to be the load tomorrow. Okay. Third is CDR analysis, doing the calling record data analysis for various kinds of reasons. Fourth is analyzing network predict failure. Okay, so you can based on the past history of the data, you can see that okay, this kind of fluctuation in the signal is generally because of the failure, and because of the failure being starting, and hence it could lead to severe f- failure. So you can predict that failure based on the past history. Government uses big data, as in the huge data, for doing the fraud detection, cybersecurity welfare, and the justice. And for healthcare and life sciences, uses, because in healthcare everything is big. Same is the case with government. So in healthcare, the health information exchange to gene sequencing to healthcare improvement and drug safety, everything is a big data problem. All right. So these are the 11 common myths about big data. It's always about above or range of the terabytes, not necessarily. Sometimes few gigabytes also become big data because of the last thing, which is called variety. Okay. Second is it always about social media and doesn't apply to me? It just so happens that gathering social media's data is the easiest thing to do, and therefore, in lots of use cases or example use cases of big data, you will find the social media data. But that does not mean it's limited to the social media. There could be many more use cases. It will replace enterprise data warehousing. No. Okay, enterprise data warehousing is good for the relational data, transactional data, and most of the big data tools, since being in the distributed nature, they are not great with the enterprise data warehousing. Okay. Yes. Parvez question is patient analytics is also there. That's right. All right. So the next is the, is it just a buzzword, no practical application? No. Has it been just a buzzword, it would have died by now. Okay, there are many more companies utilizing it, and I have seen a lot of organizations, starting with Amazon itself. Everything seems to be a big data problem. Okay, is a new concept? No, it has been there for quite some time. Will be the future? No, it's a present. All right, is expensive? No, all of the solutions are open source. It is just since because of the people, the demand of the people and the supply is, there's a difference, and therefore people are little expensive. Otherwise, the technology is really cheap. It is only for data scientists or is a magic? No. Good. The beautiful part about the current world where we are living is that most of the great algorithms are open and free. Okay, the data scientists, when they work on it, and most of them make their algorithms public and free. Similarly, you always have access to humongous data which you can churn. Okay, the other excuse I hear is from the people who don't understand big data. They think that it's all about buying new hardware. No, no. The whole premise of big data is that whatever hardware you have, we will connect it over a distributed computing and we will start using it. You don't have to buy a high end server. You don't have to buy another blade servers with 80 GB RAM. No. Average computers could be used. Alright? We will build it when we need it. Okay, so this is another excuse I hear, that we will build it when we need it. My quick answer to them is, when you need it, you won't have it, because that you won't have the data by that time. Okay, so the general strategy is to build the infrastructure, let the data accumulate, and then you can think later what all can you automate, what all can you analyze. Okay, next is, the big data is about Hadoop. No, Hadoop is just one such solution. Here is a general trend, and in this general trend, you can see that Hadoop is probably the highest in the salary trend. All right, because there was no way to figure out big data, so I've just picked Hadoop. So Thiru's question is, yeah, Thiru, I was saying this here. It will not replace EDW, although some part of EDW will be moved to big data solutions. But EDW has a lot of transactional data that won't be replaced by this new generation of the tools. All right. All right. So there are many big data solutions starting with Hadoop, Spark, Cassandra, MongoDB, Computing. Everyone has their every one of these have their benefits and downsides. So if you are open to giving away your data to Google engine, you can use Compute Engine. Okay, if you are okay to upload the data there. Okay, Google provides you a good query language on top of data and some algorithms. Okay, if you just are looking for storing data in the form of JSON object, you could use MongoDB, but it will be difficult for you to apply various kinds of distributed algorithms. Next is Cassandra. If you have data which is in tabular format and is humongous, you could use Cassandra. All right. But again, for the computing, you will have to, there will be, the computing won't be that fast on Cassandra. Okay. Next comes a combination of Spark and Hadoop. It's a combination of Spark and Hadoop. This is probably the extensive, most extensive architecture, and it's probably the best to have in your cluster. A combination of Hadoop and Spark. All right. So what exactly is Hadoop? So Parvez's question is big data can be one of the feeds to EDW to give more insights of data? Yes. All right. All right. So let's understand, what do we mean by Hadoop? Okay. So Hadoop is a software which was written based on Google file system, Google MapReduce, and Google Bigtable. So as I was telling you, Google published these three papers. Sanjay Mawat and Jeff Dean, they published these three papers. One was called Google File System, other was called Google MapReduce Computation something, Massive Parallel something, and third one was the Big Table. Based on these three, Doc Cutting and Mike Caffarella built Hadoop. And why did they build? They were basically trying to build a search engine called Nudge. They were trying to build this search engine, and they were stuck. They were stuck at a very basic problem, that even if we download, so what is a search engine? You crawl the internet, you index everything, and then you make it really, really fast to search across all of this downloaded data. So even if So I mean, dog cutting and Mike Kefler, when they were building their search engine, they were stuck at a point that where they realized that even if we build this kind of search engine, we won't be able to store the data. Okay, they did not have a great solution, and they were lucky at that point of time when they were stuck at this point. They were lucky to see that the Google had just published some paper, and they took it and implemented the file system, and that's what became Hadoop. Okay, and it was named after a toy elephant with which dog cutting son was playing, and it is open source. This is probably one of the reasons why Hadoop exists. There are many there were many other people who were doing non open source and were trying to implement the same paper, but they did not get anywhere. The reason is that if you are not open source, your adoption chances are going to be very low. So, since Hadoop was open source, that too, it was Apache license that gave them great acceptance in the industry. Okay, it's a framework to handle big data, and it's for reliable, scalable, and distributed computing. Okay, it's reliable, scalable, distributed computing. Okay, so this is the line number H is something what defines all the components under Hadoop. So initially, Hadoop was only three components, and slowly, Hadoop became an umbrella term. Okay, as of now, Hadoop, the ecosystem includes around 14 components. Okay, so all of those components which are under the umbrella of Hadoop has these three characteristics: reliable, scalable, and distributed. Okay, and it was written in Java so that it can run on any device. Prasant's question is, how different is MapR when compared to Cassandra? So Cassandra does not have any resource manager. Cassandra is a single system which stores data and you can query it. While MapR is just another version of Hadoop. It's basically Hadoop given out by MapR guys. Okay, the way you have Cloudera, the way you have Hortonworks, in the same way you have MapR. All right, so Cassandra is just one way of doing the computation. Hadoop is the full ecosystem of components. You can see here, I'll just go through all the list of components, and that should give you a good picture. Okay, so in the whole ecosystem of Hadoop, the one that's at the bottom, the one that's most important is HDFS. Okay, HDFS is most important component of Hadoop ecosystem because this is the place from where the whole magic starts. What is HDFS? It's a file system. The way you have your C colon, which is a file system provided by Windows to you, it's a NTFS file system or VFAT file system. In the same way, you have another file system called HDFS. This HDFS can store humongous data and is heavily uh, distributed. So the HDFS as opposed to your local file system. What is a file system? It has folders and files. Okay, you can keep anything inside a file. Okay, here that's why a file system is very important. It's a place where anybody can put any kind of data, unlike a database where you could only put the data in a certain structure. Here you can put data of any structure. So HDFS is the first thing. And HDFS runs on top of the whole cluster. Okay, so many computers contribute to the storage in HDFS and is heavily optimized and is very highly available. In case one computer goes down, there is somebody else. And that model is something very powerful. There is no substitute as of now, a good substitute as of now for HDFS. Okay, in HDFS you can store any data. While if you take MongoDB, Cassandra, or HBase or any other place, you'll have to store the data either in a tabular format or in a JSON format or in some other format, not like a file. While HDFS provides you that file kind of storage. All right. The next component is HBase. HBase is a NoSQL data store. A common question which people ask is, why would you use HBase when you have HDFS? Reason is, in HBase you store data in a tabular format, and not everything can fit into tabular. You want to store image, you want to store something else. You would like to store in HDFS instead of in a tabular structure. All right. Now the next component after HDFS and HBase is the compute engine. The compute engine, the storage, the file system is provided. The file system is provided is providing you. The file system is providing you the place to put your files, and these files are spread across the cluster. Okay, now but let's say you want to do some computation. Who will do that? Who will execute your logic on many computers parallelly? And that's where yarn comes into play, or MapReduce comes into play. So so the computation is done by either MapReduce or Spark. And they both run on top of yarn. Then what is yarn? Yarn is somebody like a bookkeeper who keeps track of which nodes are free, which nodes are busy, which ones have what kind of capability. So yarn makes it possible to execute anything on any node at any point of time. Okay, yarn can tell you that these nodes are free, you can use them. So yarn makes it possible for many other systems to use the cluster. Okay, and the consumers of yarn are MapReduce, Spark, and others. So Spark also asks yarn to do the things for it. And you, as a user of MapReduce Spark, you will ask MapReduce or Spark to get the work done on top of yarn. Okay, and yarn will execute your logic on the cluster or on the distributed environment. Maybe you have 20 computers, and out of those 20 there are two computers which are very fast and rest of the computers are very slow. This yarn will figure that out and will execute your logic on those nodes. Alright, Mohammed's question is, what are the new features of yarn compared to Hadoop v1? In Hadoop v1, yarn and Hadoop were both part of Hadoop. So Hadoop was broken down into two parts. One that does the work of a supervisor, keeping track of which nodes are free, which nodes are busy, which computers are is heavily loaded, and so on. Okay, in Hadoop 1.0, both works of actual MapReduce and resource management was done by MapReduce. or you can say Hadoop. There was only a single component. Later on, people realized that the same component, like yarn, could be used by many other services. The resource management could be used by many other services the way it's being used by MapReduce. So they broke it into two parts. And now, by virtue of version 2.0, as of today, as of today, Yarn is being used by more than 20 services. Okay, for that matter, Spark also runs on top of Yarn. Spark was never possible in Hadoop 1.0. Sukhvinder's question is, are all these HDFS, HBase, MapReduce, Spark, Yarn exist on the same machine? No, they they are distributed. I would like to show you right now because this is the right time. Let's say I go to my cluster. Okay, so I'm opening something called Ambari. Okay, Ambari, using Ambari, we install things on our machines and so on. Okay, I've logged in into admin, although I could log in into my account as well. So you can see that there are these three services we have shut down. So you can see that we have name node, secondary name node, data node, and so on. And all of these services are running on 5 different servers. Some services are running on first one, some services are second one, and so on. All right. So Arun's question is, so yarn is something that runs in the background and no intervention or instruction from the user are needed for processing or something. Yes. Okay, you can think of yarn as an operating system. Okay, operating system without a user interface. All right. Vivek's question is, if MapReduce and Spark are both computing engine, what's the difference between the two? Do we need both or one of them? Okay. Spark utilizes memory. So you would generally end up consuming the RAM in case of Spark, while in case of MapReduce, you don't. It is very much optimized for low memory. Also, Spark has been fairly proven and old, while MapReduce is quite proven and old, while Spark is comparatively new. So the libraries are being built for Spark these days. Did I make sense, Vivek? Was I able to answer your question related to Hadoop version V1 and V2? Rajiv's question is, how do you go to CLI from Ambari? There is no command line interface provided by Ambari. We have installed our own. Okay, so you could either use SSH and go to H5, or you could simply click on Web Console and copy your login password here. Okay, so I'm copying my login password. Alright, so this is my console. This is my console where I would be typing commands to interact with various things. Say I'm right now talking to Hadoop file system. Okay, this is Hadoop file system. Then I can talk to Pig by typing a command here. Okay, so those who are comfortable with command prompt would like to use this web console. In case you are not comfortable, then you can go to Hue. Using Hue, you can operate with all these systems. Okay, while Ambari is only for administration, Hue is to operate on anything. For example, let's see how does the HDFS looks like. It's it looks like a normal file system. You can see that these are my files. Okay, so Parvez's question is yarn same as kernel in Unix and Linux? The analogy is good. Yes, you can take the analogy. Ambari is some kind of a tool, right? That's Ashok's question. Yes. It's basically a tool with which you can install things. And I remember I think Sukhvinder was asking about if he can set up a three nodes cluster. If you're trying to do that, go with Ambari. It'll be quite quick. All right. Asmit's question was which is best, Spark or MapReduce? So far, Spark is being doing good so far, but again it is a memory, it consumes a lot of memory, so it might not leave space for other processes. All right, so that's about the compute engine. Now with MapReduce for the computation, it was every time you have to do something you would end up writing Java code, which was not acceptable and which is not really practical. So some people came up with the idea saying that let's write a SQL engine. And this SQL engine is called Hive. It takes SQL from you, understands the SQL, and convert the SQL into MapReduce. All right, that's where the Hive comes into play. All right, I'll come to Flume and Scoop later. All right, next, similar to Hive, some people realize that SQL is not doing justice to the new paradigm. So they wrote a language which is, you can say, a simplified SQL, okay, very simplified SQL called Pig Latin. It is for, just like SQL is used to analyze data, similarly, Pig Latin is also used for analyzing data. All right, now there is something called machine learning. This is the magician with you. Machine learning library called Mahat comes up with a collection of algorithms such as generating recommendation or doing the clustering or we'll talk about all of these in details. So based on, because there are many complex algorithms which are not there in SQL. Okay, for that you have Mahat kind of library. All right. So Mohsin's question is, what is the role of HBase in Hadoop? So in HBase, NoSQL or HBase, you store the data in tabular format. The way you store in RDBMS, in the same way you store data in HBase. The only difference is HBase has been designed bottom up for the complete big data solution. Okay, HBase has been designed for big data. All right, HBase, let me just go back to HBase. So HBase is a NoSQL data store, meaning it's not like a relational database, but it's a data store where you can store the data in a tabular format. Therefore, you'll have to convert your information into tabular format. And also, HBase provides arbitrary data manipulation. Okay, per you can create record, update record, delete record, and so on. All right. So, and this HBase is running on Hadoop itself. It's running on top of HDFS, and it's also utilizing yarn. All right. I hope everybody is with me. So that's our machine learning library. And then you have at the bottom, you have Flume. What does Flume do? Flume imports unstructured data into HDFS. Okay, if you are moving movies or you're moving videos and lots of files continuously, then you use Flume. In case you want to import in case you want to import data from, say, Oracle, MySQL, or Microsoft SQL, you can use Scoop. Vijay's question is, so HBase stores both structured and unstructured data. That's right. All right. So Kvinder's question is, DMLs can be performed on no-RAMI DBMS. Okay. But how HBase is different? So HBase runs on hundreds of computers in parallel. Some records on one, some records on another, some records on some other. Okay, which means it can handle humongous loads, humongous write operations, many people trying to manipulate many records parallelly. That kind of problem can be very well solved by HBase. Ashok is saying that talk to Mahat need to write code in Java or Python. No, you don't have to. You can actually use Hadoop, Mahat's library as a command line. So Mahat provides a command line also using which you can do a lot of work. Okay, so you don't have to write code in Java. So Asmit's question is, Flume is also works on real time? Yes. Flume in real time pushes the data into HDFS. Parvez's question is, can HBase be replaced by MongoDB and Cassandra? Yes and no. First, HBase is fairly faster and is better in the comparison to MongoDB and now Cassandra as well. Okay. Second, HBase runs on top of Yarn and Mahat. It runs on top of Hadoop. Therefore, it's not possible. Therefore, you don't have to set up a separate cluster. While MongoDB does not run on top of Hadoop, so you might have to set up your own cluster. All right. A question from Vijay. So in this architecture, instead of HBase, we can use Cassandra or MongoDB. I hope you got the answer. You, Vijay and Parvez have exactly same questions. This is interesting. Okay. This is where, yeah. All right. A question from Syed. Question is, what is the difference between HBase and Hive? HBase provides manipulation of the records like create record, delete record, update record, while Hive does not. Hive does not provide. Hive provides you only the read-only operations. Vishnu says how HBase knows which tabular format the data needs to be stored. It does not. You will have to upload it by yourself. It does not know how to store that. Okay, another question from Vishnu is if HBase requires user intervention, what language is that? The interesting part of HBase is it does not have a SQL. It does not have any language. Instead, it has very simple command called get and put. Okay, it's very simple. Okay, so yeah. So Vijay's question is, it's if HBase is not integrated with, so what I was saying is Cassandra and MongoDB is not integrated well into Hadoop architecture, while HBase is well integrated into Hadoop. So Ashok's question is, Pig does the same thing as Hive, almost same thing, just that Pig is a slightly different syntax, which has been designed for distributed computing. Okay, so Anand is saying that since we can update records in HBase, how does it how does it handle scenario where multiple users try to update the same record at the same time? Okay, so answer to that question is that the whole row is can be logged very well. Okay, the whole row. So HBase only provides row level transactions. All right, now there are few more things here. One is called Uzi. Uzi basically provides you kind of a workflow engine. What does it mean by a workflow? Let's imagine that you are building a recommendation engine. Let's imagine that you're building a recommendation engine, and what does it require to do the recommendation engine? First, copying the data into HDFS, then writing your cleaning this data, converting it into kind of a comma separated values, and so on. And once that's done, when you have reformatted the data, then you would like to give it to Mahat because Mahat needs three column data. And once Mahat is done, you would like to move the recommendation to your web server. Now, if you think about all of these steps, there would be more than 12 steps. There will be more than 12 steps, and those 12 steps, if done manually, would be error prone. Therefore, there is a workflow engine called Uzi where you could go and say, first copy the data to HDFS, and then once you have uploaded it to HDFS, then clean it and make three columns out of it. And once three columns are done, call Mahat on the same data. And once Mahat is finished, whatever is the output of the Mahat, to you copy that to some web server. Okay, so all of these things could be chained together into Uzi. Okay, so that you don't have to keep doing it manually over and over. Also, Uzi provides you kind of a scheduler where you could say that here is my script. Can you run it every day? Okay, so that is Uzi. All right. All right. Vishnu's question is, what is the format in which data is stored in HBase? HBase provides you kind of a tabular data structure in which you put into table the columns and their values. Okay. And internally, HBase convert that into small files which are being stored in HDFS. The way MySQL stores data in the local file system, similarly, HBase stores the data into the HDFS. Yes, Ashok, it's a kind of command. So Leela is saying, is Uzi like a batch program in Unix? Kind of, yes. Okay. It's basically you give an XML file, you give an XML file containing the steps saying first do this, then do this, then do that. Okay. And then you upload that XML file into the Uzi console saying that here is my job. Can you keep executing it at this frequency? All right. So that is Uzi. All right. So these were the many components which we have discussed, except for one more component which is not mentioned here. We will also discuss Zookeeper. Okay. We will also discuss Zookeeper as part of this course. So Sneha's question is, Uzi includes queries or programs? Yes. So when we say, can you execute this particular script at 3 o'clock? Then we can upload that script and give the handle to Uzi. Thiru is saying overall performance for reading data from HDFS is slower than RDBMS. Okay, is that assumption correct? No. If the data is huge, the overall performance to read from RDBMS might be really slow. Yes, yes, Arun. The zookeeper is not in the diagram, but if I had to put the zookeeper in the diagram, it would come parallel to HDFS because zookeeper does not depend on anybody. Zookeeper is a standalone system to maintain coordination. All right. Rati's question is this all Hadoop processing happens on offline data? The live data has to be loaded from the live data. Yes. So you can see that the Flume is generally used to load the live data. Okay. So most of these scripts which you see like MapReduce, Hive, Pig, and so on are great for static data, relatively static data. So Prashant's question is, would you be able to cover security aspect with Apache Sentry? Not yet. Not yet. We have not gone through the Apache Sentry yet. Okay. Prashant is saying that I would like to know. Yeah. So Prashant, we can take it offline. We can discuss. So Vivek's question is, what does yarn represents? Yarn means yet another resource negotiator. Basically, with with yarn, you say that can you get me this much memory and this many CPUs? Okay, and yarn goes to every node and negotiate with them. All right. So that's about it. So we have CloudX Lab. You already have seen this section. Okay, and this is a real cluster where you can try everything. Okay, okay, go through the Cloud Labs. Here are the links. When you log in into my course, you will see all these details. So you log in into your account and use these links instead of these links. Okay, so go through Cloud Labs, understand, go through LMS, and if you want to set up your Hadoop environment, the details are also provided in LMS session 1. Okay, you can attend to the half quiz from first session. Okay, the rest half would be covered tomorrow. All right. Sayed is saying it seems like a person should do many coding languages like Hive, Pig, Java, HBase to access big data solution. So these are not too difficult. Hive is more like very similar to SQL. Pig is actually extremely simple. Okay, extremely simple. We will teach you. Okay, and then Java is, we need only basics. We need only basics. We need only basics. Okay. HBase is extremely simple. You only need to understand concepts. All right, Sayed, and so on. Leela is saying, is there admin console? Yes. This is, if you go to Ambari, that is our admin console. Okay. It's just that you can't provision because you have only read-only access. Okay, another question from Parvez. Is Hive Does Hive read data directly from HBase to execute query? Yes, it can read. Hive can read data from HBase. It can read data from HDFS and so on. The live transaction could pose big data problem. So Hadoop is not a, a solution to that. Not yet. Not yet. And also, if you, we will talk about something called cap theorem, which says that if you try to make something consistent, it becomes difficult to distribute. Okay, so we'll talk about cap theorem and other parts in session number 6. All right, makes sense to you? So I'll just take you through this. So when you log in, you will see Ambari, Hue, and Web Console. Ambari means the administrative console where you can see how many, so you could go to dashboard. It shows that this is the total SDFS storage. Okay, we'll talk about what does it mean tomorrow. It shows that resource manager heap is 8% used. So it's basically showing you the aggregate details. And then under hosts, you can see that there are 5 hosts as of now. All right. So this is administrative console. But if you go into not here, but here, this is the terminal where you can type commands. It's a full-fledged Unix terminal. It's not parallelized. You can see that you can even run things like Python and things like R. Okay? From the same terminal, you can actually use all these commands. All right? So next is Hue. Using Hue, you can interact with almost every tool. You can talk to HBase, you can talk to Zookeeper, you can talk to Scoop, you can talk to Hive metatables, and you can create the Oozy workflows and so on. Okay, you can see you can interact with Hive, Impala, DBQuery, Pig, Job Designer, Spark, and so on. All right, makes sense to you? Now, next question from Vijay is, you said big data does not address live data transactions. So it means big data is only for non-transactional data store. But there are not always you need transactions. Okay. All right. So Impala is another tool. Okay. We won't be diving into the details right now. All right. All right. So Impala is basically kind of data engine provided by Hortonworks. All right. So you can see that you can, these are the example databases. If you want, you can use those. All right. So that's pretty much. And okay, that's pretty much for today. Feel free to reach out to me if you have any questions. And we will continue our discussion on HDFS tomorrow. All right. We'll continue our discussion on HDFS tomorrow. All right. This is wrong. Second session. What is tomorrow? Tomorrow is 7 February. This is wrong. All right. This is not right. All right. This is not right. Okay. All right. So Leela, you could go here, and if you go into my courses after logging in, you can go here. It shows you the details about all the things. I'll just go to another course. Okay. So here is the course. All right. So here is the quiz. You can attend to the quiz. All right. That's pretty much, and you can attend to the quiz. All right. So if you have any questions, feel free to reach out to me at support@nobigdata or reach us at nobigdata, any of the email IDs. All right. See you tomorrow at the same time. All right. Bye bye. Have a great day. I'm happy, Suraj, you find it a wonderful session. I'll try to uh, keep all of you active from tomorrow onwards. All right. Bye bye. Have a great day. Bye. Good night, all of you.